When people hear the term aerial or drone survey, they often think it's just photos or videos from the air. But in reality, a drone survey produces multiple datasets, each serving a different purpose, and each useful for engineering, planning, construction, and analysis. In this video, we'll break down the main datasets you can expect from a drone survey, what they are, and how they're commonly used. The first and most common output is an orthomosaic map. An orthomosaic is a high-resolution, georeferenced map created by stitching hundreds or thousands of drone images together. Unlike regular photos, it's corrected for distortion, camera angle, and terrain height, which means you can measure directly on it. You can use an orthomosaic to measure distances and areas, identify features and boundaries, support planning and site assessments, track progress on construction sites. Think of it as a very detailed, up-to-date satellite image, but with much higher resolution. Another key dataset from a drone survey is the point cloud. A point cloud is a collection of millions of 3D points, each with an X, Y, and Z coordinate. Together, these points form a 3D representation of the surveyed area. Point clouds are used to capture terrain and surface geometry, measure heights and elevations, generate 3D models, support CAD, BIM, and GIS workflows. They're especially valuable because they retain true 3D information, not just a flat image. From the point cloud, you can generate a digital surface model, or DSM. A DSM represents the elevation of everything on the surface, including buildings, trees, vehicles, and other objects. It shows the highest point at every location. DSM data is commonly used for drainage and runoff analysis, visibility and line-of-sight studies, urban planning, environmental assessments. It's essentially a 3D height map of the surface as it exists. Next is the Digital Terrain Model, or DTM. Unlike a DSM, a DTM represents the bare earth. Vegetation, buildings, and other objects are filtered out, leaving only the ground surface. DTMS are critical for engineering design, earthworks and cut-and-fill calculations, flood modelling, road and infrastructure planning. This dataset gives engineers a clean, accurate representation of the terrain beneath everything else. Another common output from drone surveys is contour lines. Contours are derived from elevation models and represent lines of equal height. They help visualize slope, terrain shape, and elevation changes across the site. Contour data is often used for site planning, road and drainage design, land development, topographic mapping. Contours turn complex elevation data into something easy to interpret on drawings and maps. Drone surveys can also produce a 3D mesh model. A mesh is a textured 3D surface created from the point cloud and images. It looks realistic and is ideal for visualization. Mesh models are commonly used for project presentations, architectural visualization, virtual site inspections, stakeholder communication. While not always used for precise measurements, meshes are excellent for understanding context and scale. All these datasets can be exported in formats that work with common software. Orthomosaics as GeoTIFF or JPG. Point clouds as LAS, LAZ, or XYZ. Elevation models as GeoTIFF. Contours as DXF or SHP. Mesh models as OBJ or FBX. This makes drone survey data easy to integrate into keyed, GIS, BIM, and planning workflows. So when you commission an aerial or drone survey, you're not just getting images. You're getting a complete set of spatial datasets that can support design, analysis, monitoring, and decision-making. From orthomosaics and point clouds to terrain models, contours, and volumes, drone surveys provide fast, accurate, and flexible data for a wide range of industries. If you'd like a deeper dive into any of these datasets or want to see real examples, drop a comment below and make sure like and subscribe for more videos like this. Thanks for watching, and we'll see you on the next one.